Hey everyone! In this video I want to teach you about modeling in R. Now, modeling can mean a lot of different things. Today we're going to focus on more of the practical dimensions of modeling. If you've not had any background in basic statistics, you're going to want to make sure that you acquire that knowledge somewhere else. This is really about the technical implementation of modeling in R. So obviously in the kind of ideal situation, we would be able to run a lot more experiments. But often in computational social science, there's logistical challenges. Even if there are some really great new opportunities, there's still a lot of obstacles, right? Ethics, costs, logistics, and so on. So very often we're in the business of modeling or analyzing observational data that was created by taking simple observations of human behavior instead of assigning them to treatment and control groups. So we'll talk a little bit today about how to do some observational analysis in R. We're going to look at some kind of very basic techniques, and I'll briefly allude to some more advanced topics that you'll want to get to know as you proceed. Okay, so let's motivate this discussion with a little example. On my desktop here, I'm opening up a pretty interesting data set. So the Washington Post, about a year ago, released a data set that described every single pharmacy in the United States and how many opioid pills it had prescribed in the previous 2 or 3 years. So a friend of mine and I scraped that data and compiled it into this database, and it's organized by county. So as I open up the data here, you'll see we have different counties. And then we have this variable, the number of pills that were sold in each county. So the number is huge, right? Because they're individual patients, but they're each given large numbers of pills typically. Okay, so we're going to kind of explore two ideas that are out in the popular imagination there. This is not my field of expertise, but in the popular imagination, there's kind of two ideas out there about opioids around now. And that is that one is that opioid addiction was affecting parts of the country that lean towards the Republican Party more strongly than others. And then another idea that was out there was that Obamacare, President Obama's signature healthcare policy, was actually increasing opioid prescription because it was giving people who otherwise wouldn't have the means the ability to acquire drugs. So those are kind of two, again, very lay ideas. I personally don't know what the actual consensus is in the literature, but let's just take a peek with this literature, with this data here. Okay, I'm just going to go ahead and load a few packages. Tidyverse. Let's also load ggplot. And let's begin simply by looking at bivariate relationships between those two variables. So in my opioid data here, I have one variable that's called num pills, and that's the number of pills prescribed in each county. And then I have another one that is called Republican vote. And I'm going to add just one layer on here. Let's just add a simple geom point here. Let's make it a little prettier. Theme. Okay. So let's go ahead and take a look at this. Now, as you can see in this plot here, it's kind of tough to see with the naked eye what the relationship is here. We very clearly have some outliers up here, some small counties which were actually written about at length in the Washington Post about where there were just a ton of opioid pills described. So that's kind of makes it hard to see the trend, right? If we could, for example, cut down the y-axis to try to get a better sense of count down the size of the y-axis to try to get a better sense here. Let's see what that does. And it's still pretty tricky to figure out what's going on here. It looks like a pretty difficult to model kind of relationship. So what we might do in this type of situation is add a regression line to this bivariate scatter plot here. And the way we do that in R is add a layer to our ggplot called geom_smooth. Now geom_smooth can produce a smooth line with lots of different techniques. We're just going to use a simple, what's called a linear model, which is simply going to draw a line that minimizes the distance between all the points. And we also have to specify the formula here. In R, you always specify the outcome variable followed by tilde and then the predictor variable. So here we're just going to say y equals x. And I just have to add a plus to the end of that layer. Let's take a look at that. So here we have something that kind of is maybe a little surprising. We're seeing a very, modest, but, substantial negative trend. So according to this plot, what we're seeing is the more the Republican vote there is, the fewer pills that were prescribed. So that runs counter to what we were expecting. Let's take a look at Obamacare. So here I'm going to replace Republican vote with a variable in this data set called Obamacare. Let's do this once again. Here again, we've got some outliers, some extreme observations with extreme values that are clearly driving the results, like this one up here or this one up here. But we see a modest positive trend, right, in line with the idea that Obamacare, here the percentage of the population that's on Obamacare in each county, is somehow driving the number of pills that are being prescribed. So, okay, so as everyone should know who takes a basic statistics class, correlation is not causation, right? There could be any number of other confounding variables that kind of explain away these two relationships that we've seen. So suppose we want to take a look at some of those possible confounding variables or confounding factors. A very obvious one might simply be population size, right? The number of pills is going to be driven a lot by how many people live in that county. The more people there are, the more people who might get, have a car accident and then get prescribed opioids, right? So in order to do that, we typically use something like a multivariate regression model. Now again, this is a primer on kind of the technical part of how to apply multivariate regression. If this is the first time you're hearing about regression or multivariate regression, you're going to want to look at some of the other resources linked on the website for this video. But in R, we can write a simple linear model. In base R, we can just write LM. And then we name our outcome, the thing we want to explain. So here we might put number of pills. Then we use the tilde to describe everything we want to predict that outcome. So here, let's first try Republican vote. And then if we want multiple predictors, we simply add the plus sign. And so now I'm going to add population to our model here. And the last thing I need to do is add data equals opioid data, because I could specify, and I could run a regression on any data set I have open. Now, this will only output part of the kind of regression output. To see the full output, I have to wrap all of this in summary. And when I run this line, what we see in the console here is the output of our regression. And here, interpreting this stuff is very complicated, in part because these two variables are measured on different scales. So our population can range from 0 to tens and tens of thousands or hundreds of thousands, and our Republican vote variable only varies from 0 to 1 because it's a percentage variable. So we can't really make much of the size of these coefficients. It's particularly difficult to interpret because it's in scientific notation. But what we can do kind of crudely is see whether they're positive or negative. And here we see we still do see a positive relationship. Earlier we saw negative relationships, so now we're seeing a positive relationship. But really what's driving everything here is population size, right? And here we see, according to these significance scars, that this is significant at the 0.001 level. So looks like population indeed was a confounding factor for the relationship between Republican vote and number of pills. In fact, we saw the sign of the relationship, the direction of the relationship, change once we accounted for population. Let's take a look at Obamacare. Simply replacing Republican vote in the model with Obamacare. Here, once again, we see population has a highly significant positive effect with the outcome. And here we see the effect of Obamacare is not significant, and it actually has a negative relationship instead of the positive relationship that we saw in the bivariate plot that we just made. Okay, so these are just very, very basic ways of looking at models. Now, one thing we would really want to do is think really about whether these relationships are linear. So if we go back up to our ggplot up here, one really nice thing that ggplot offers is a smoother that can account for kind of non-linearity, something called a generalized additive model. And if we apply that, we can see a little bit more about whether this relationship is really non-linear. This one looks still pretty linear. Let's try out Republican vote. And here what we're trying to see is, are there differences between places where, I don't know, half the county votes Republican and 99% of the county votes Republican. And here again, we see a relatively linear trend. But this geom smooth function could help us detect whether there are nonlinear dimensions to this relationship, in which case we'd want to think carefully about how to transform that variable. We're going to make lots of assumptions in any kind of multivariate regression. Typically, we're violating a lot of those assumptions. You know, in general, this is an approximation, right? You probably, or you may have heard the saying, all models are wrong, but some are useful. So we're violating assumptions left and right, often when we're doing this type of regression. But the question is kind of how severe the violations are and what we can do to mitigate them. Another thing we'd want to look at is whether the outcome is highly skewed. We might want to specify a different family of regression techniques, for example, a logit model or something of that nature. And again, if you haven't learned much about multivariate regression, this might be all new to you. I encourage you to check out some of the resources in the video notes today. Last thing I want to say, just a very practical point. Very often when you're running your first few models, you may be unaware that you have lots of missing data in your data set. This particular data set only has a few rows of missing data. But even with those a few rows, R by default is going to do what's called list-wise deletion. That means any row that contains any missing data on one of the variables that's in your model is going to be dropped from the analysis. Now, you're going to want to learn more about missing data and how to model missing data, learn about things maybe like multiple imputation techniques if you really want to get into how to solve missing data problems. But for now, I just want you to know that that can have a substantial impact on your analysis. If, for example, one of the key things you're looking at is a relationship between, say, income and health, but income, which is very often measured, producing a lot of missing data because people can't estimate their income well or can't estimate their family income well or something like that, then actually the missingness of the data could be a pattern that's driving the results itself. So be aware broadly of missing data and learn how to browse your data. I'm always an advocate of browsing, looking at your data in different ways to try to detect when these types of things might be driving your results.